Hi, welcome to COMP501 Foundation of Programming. In this lecture, I will talk about abstract data types. So what is an abstract data type? An abstract data type, or ADT, is a data type described by predefined user operation, such as insert data at rear, without indicating how each operation is implemented. In other words, you know what operation is there, but you don't know how they did that. A ADT can be implemented using different underlying data structure. This is programmer doesn't need to know the knowledge of underlying implementation to use the ADT. For example, you have learned how to add data to the list, like list.append with a new value, but do you know how that was done? We've been using it, list or string or dictionary with many operations, but do you know how they did underneath that? Most importantly, do you need to know how they did it? Well, most of the time you don't need to know how they did it. You just need to know how to use it. But sometimes, if you want to find some, maybe if you want to learn more about how they did it, you could. And these are some of the common ADT. The one that I highlighted in bold are the one that we're going to talk more in detail. List is an ADT that hold order data. We're going to talk about linked list. Stack is an ADT in which item only insert or remove from the top of a stack, like stack of paper, stack of plate. Queue is an ADT in which items are inserted at one end, at the end, and removed at the front of the queue. This is very similar to the checkout line. Deck is an ADT in which item can be inserted and removed in either end, either front or the rear. Then there are bag, set, priority queue, and dictionary. We will learn this in the future courses. So again, a application mean to have the user interaction in the item at a high level, with lower level internal detail hidden from user. This is one of the principles of object-oriented programming. It's called encapsulation or data hiding. ADT support abstraction by hiding the underlying implementation detail and providing a well-defined set of operations or using it. For example, if you think about driving a car, since self-driving car is one of the hot topic, what are the well-defined set of operations for driving a car? How do you drive a car? And most importantly, how do you avoid accident when driving a car? Driving a car is easy, but how to avoid its accident is not that easy, right? So these are a lot of things you need to do to move forward, to move backward. You need to check things. And using abstract data type enable programmers or algorithm designers to focus on higher level operation and an algorithm and improve efficiency. Again, this is principle of the object-oriented programming called encapsulation. For example, if I say for you to drive a car, do you need to know how the engine work in a car in order to drive a car? Everybody know how to turn on and change volume or channel in a TV or a computer, but do you need to know how they implement that when you press a button on your remote or press a keyboard, a key in your keyboard? What happened to that key that you just pressed? Not really, right? You just need to know how to use it. You don't need to know how to implement it. But sometimes knowledge of the underlying implementation is needed to analyze or improve the runtime efficiency. You don't need to know how to use it, but if you find out the algorithm they have chosen is not that efficient, maybe you need to figure out how did they implement that. This is kind of rare. Most programming language provides some standard library or modules that implement the most common abstract data type. And some languages allow programmers to choose the underlying data structure used for the ADT. Other programming languages may use a specific data structure to implement each ADT or may automatically choose the underlying data structure. Python has, you have learned, list, set, dictionary, deck. Other common programming language like C++ have what they call the standard template library, STL. Vector is like an array. List, um, deck, queue, stack, set, map. Java has collection, set, list, map, queue, deck, and other programming language also has very similar ADT. And the list is probably one of the most common ADT for holding order data type. It doesn't have to be order, but it can be unordered too. Having operation like append a data item, remove a data item, and search where the data item exists and print the list. Again, user need not have knowledge of the internal implementation of the list ADT. You just need to know what are the function or method the list ADT support. And here just an example. This is just a hypothetical example. Common list operation. You can append or prepend. Append insert at the end. Prepend insert at the start. And insert after some index or some value. Remove a list, search, print, reverse, sort is empty, and get length. These are some of the common operations, and some of these may look familiar to you. Get length, well, we have a len, the length function. Is empty, you can check for whether this is a null, empty string or empty list. Sort, hey, for the list, you have a list.sort. Reverse, for the list, they also have a list.reverse function that refers the list. You know how to print a list, you know how to search a list. So these are some of the operations we have learned or used, and now we're going to see how we're going to implement those. So we are going to go and look at the implementation of ADT. Thank you.